Right, in this video I'm going to show you how to make this 2MT taper backplate for the Nano 80mm self-centering 4-jaw chuck. And this is the chuck that I use for a screw tapping chuck. It's an excellent chuck. You put the screw tap in the jaws on the actual square, and this prevents it from spinning in the chuck. And the actual backplate can be made up very easily and quickly using this 2MT soft machinable arbor, which you can buy on eBay. I think I bought 5 of these from Kronos for a very good price. And then there's this 80mm mild steel disc. It's a bar end. It's 8mm thick, and there's a seller selling these on eBay at the moment. Using these 2 items you can easily make this backplate up. So in this video you'll see the full process of me making this backplate up on the Chinese mini lathe, and several tricks and things that I've learned to use to actually machine large diameter work like this. Right, so the first thing I do with making this backplate for this 80mm chuck is to use this disc, which I got off of eBay. It's listed as a 80mm disc and it's 8mm wide. And you can actually see that it's a bar end and has come from a machine shop or an engineering factory. Whatever was on there was parted off, and this end is unmachined, so it's important to put it into the chuck on the mini lathe, the machine end on the actual back face of the jaws. And on my lathe I'm using the 125mm chuck. I can't be bothered to actually change it over to the 100mm chuck that I have. If I had the 100mm chuck up here, I reckon this would probably hold on the front step of the jaws. But because I'm using this one, I have to hold on the back step. And all that means is that I have to take extra care when I'm actually facing this off, that I don't actually crash the tool in the edge of the jaws. Another thing on the Chinese mini lathe is that the cross slide won't come back far enough. I could actually move the tool back further in the actual holder here, but I'm not going to do that because I'm going to overcome both problems using the same idea. All I have to do is loosen the quick change tool post like that and put it at an angle so that I miss the edge of the jaws and I can face off safely. And that's another great thing I like about these DCMT 070204 insert tools, because they have these angles and it's a narrow insert. You can actually turn it at a different angle, quite a variety of different angles, and it will still cut perfectly. So that's solved both problems. I can get the tool back far enough now, plus I can actually get it into the second step without actually crashing on the edge of the jaws here. And it's what we call in Britain killing 2 birds with 1 stone. And I always check first, turn the chuck to see that nothing is going to hit before I turn the machine on. And that's cleaned up lovely. So now I turn the billet round and I've got just enough on this side to actually face this end off. I'm not too worried about this end as long as one end is nicely cleaned up, but I'll try and tidy this end up as well. So you can see there's a bit of a dip there and it hasn't cleaned up quite in the center there, but that doesn't matter because this is going to get drilled and bored out. I just removed the pip in the center there so that it doesn't put the center drill off. And just to finish, skim with this tool. And I've machined that bore to about 25mm in diameter, and I've deburred both ends with that scraper tool that you just saw, and I've actually left that bore a little bit liney, and that's for the Loctite 638. So if you want to get a liney finish like that, you have slow revs and move the boring bar through quite fast, and then come out and come back so it doesn't actually touch on the way back, and that gives a really good finish for Loctite 638 to harden into. So the 2MT arbor that I've got with this soft head, which I can actually turn down, this is 28mm and the bore is 25mm, so I've got about 3mm to take off of this one to actually fit that bore. So I put this one in the chuck now, holding on roughly probably about 300 thou on this diameter, and I actually clock this one in, and that's within a thou, so that's perfectly alright. So now I've set my stop on the lathe, and I'm going to turn this one down to actually fit that bore. And then I put an undercut at the back. So that one now fits nicely all the way down, and with Loctite 638 you can have about 2 thou clearance if you want to. So this one's going to go right up hard against that shoulder. So now I just mark the diameter and put a couple of grooves in there with the same tool for the Loctite 638. So now I fill those grooves with the Loctite 638. I haven't got a spout on the bottle of the Loctite 638, so I use this stick and it actually puts it in there nicely. And it doesn't matter how much you put on, just make sure it's all covered, and there's plenty of Loctite 638 in those grooves all the way round. And I do actually put a little bit in the actual bore of the other component. So now that one can go down over that, or twist it as it goes down, and just hold that one in place for a few minutes, and that'll go off rock solid. And you can heat it up a little bit if you want to, if it's cold weather, just to make that go off. And all the while I'm doing this, I haven't taken the arbor out of the jaws at all, so everything remains the same and it's running dead true. So next I face the end of the arbor off. And I have actually left the arbor about 10 thou plus to the actual backplate. And then I check the depth of the register on the chuck and set my stop with the turning tool to actually go down. The register on that one is about 4mm deep. All as you need to do is go about 2mm deep. So this is the setup. I've got my stop set and I've turned the tool post at an angle again so I can actually get out the diameter. And now I'm ready to turn that register diameter to fit the bore on the back of the chuck. And it's all still running dead true because I haven't taken it out from the chuck at all. I've recentered this end here, and you'll see that I centered it when I was actually facing it off, because it's much easier to face off into a small hole than facing it off and then pushing the pip at the end. So now I can actually put the tailstock center in there to give it more support when I'm doing the turning. And I actually look at the back of the chuck and see roughly how far I've got to go down on the diameter. But if you want to, you can actually get something, a disc or something that size, and then hold it on the front of this disc here and draw around it to give a rough guide of where you've got to go to. And that's because you don't want to get to this stage and then actually make an error on this register and ruin the whole thing. and that one's bang on. So now I'll let the stop in about 10 thou, and I'll just skim down the shoulder. And that's the turning finished. And because I'm only using this tailstock backplate with the 80mm chuck in the tailstock, there's no need to do any more to actually hold this flange on the arbor. If you're going to use it in like a spindle and use it so you can actually turn with it, it would actually be best to TIG weld around that diameter there on the front there. And if you remember, I said that it was about 10 thou protruding. You can use a tool like this. It's a ball bearing in the end there, set in the end of a piece of mild steel, and you can actually use this to actually swage that diameter on the actual arbor over by pressing it on the front with the spindle turning. And this is a tool that I made up specifically for this type of thing. So I touch it on the join of that arbor and the actual flange, and then push the tool in quite hard on that face, and it'll actually swage that 10 thou over. And you don't have to do that if you're going to just use it for the tapping chuck. And now all I have to do is get the drill holes in position for actually screwing the chuck onto this back plate. And these Sanu 80mm 4-jaw self-centering chucks only have the screw thread on the back of the chuck. They don't go right the way through like on some chucks. Most of the chucks are like this now. So you have to use transfer screws to actually transfer the indent onto the back plate ready for drilling. And you can actually make these transfer screws very easily. All it is a grub screw and then an Allen key that actually fits that grub screw. You grind a piece off on the corner of a grinding wheel and do it to a point, and then you screw the grub screw into the chuck down to where it is nearly flush with the back face here, and then drop that piece of pointed Allen key in the hole there, and then you can see from the side here that the points are protruding about 1mm from the end face here. You have to screw it down as far as you can so that this diameter, the register diameter, actually goes into the bore a little bit. And you also have to feel to see whether those points are equally protruding from the back. If they're not, you can actually tip it like that. So you have to find where it is nice and level like that one is now, and then you put this into the bore and give it a whack on the top here with a copper mallet. And I have found the real dead accurate way of actually grinding those pieces of Allen key, because these 6mm thread here, the Allen key is quite small. What I do is put the cut off piece of Allen key in a long grub screw like this one here, and then just pretend this swerve figure 10 here is the wheel. You put it onto the grinding wheel like that and spin it like that until it's a perfect point. And it's surprising how accurate you can actually get those pieces. And like I say, with the 6mm ones, it's best to use a magnet to retrieve that piece. So I can drop that one back in now. Incidentally, I've made the 8mm set as well for the other size chucks. Put that on the back. And this is a thick aluminium plate tabletop here, which I hold in my vise. So you hold the back plate on the chuck like that, nice and firmly, and give it one quick tap with the copper mallet on the back there. You can put a piece of wood on the back there if you want to, but this won't harm it. And then you have the 3 indents to drill for the through bore for the 6mm screws or Allen bolts. And that's a dead accurate method of actually getting the screw holes in the correct positions. So that's the drilling finished, and all I did was actually hold it in the vise like that and drilled through with a pilot drill, then a 6mm drill, and then to finish off a clearance of 7mm. And it is actually spot on, like I say, from using those transfer screws. The transfer screws are kept in there, and I keep these with my transfer punches ready for next time. And I actually like this one much better than the original one that I made. This one's much thicker here, so on the mini lathe where room is limited, this one is much thinner and allows me much more clearance on the tailstock. And then I use stainless steel Allen bolt 6mm, and these were an inch long, but I've cut them down to 18mm long. So you want the maximum amount of threads going through into the chuck without it actually bottoming out. And I think that's just about maximum. And that's the job finished.